Greetings from Dystopia, episode 228. Back on the bench. More RasPi stuff. Follow up to the Visa plate and the IoT project. I talked to Jeremy back and forth in a few emails, and they found out in school that the 0 was not strong enough as an MQTT broker. It just created some latency while it was processing that wasn't good to go. I've not had that problem, but then again, I'm not that heavy on it. It's not a bunch of students banging away on it. And we figured just to give him more headroom, we nixed the entire Visa plate idea and went with a DIN rail mount rig that we built. I built this one and he'll build his own from there. But yeah, basically we took the Visa mount and the the DIN rail mount and a piece of just the plain PCB and stacked up, again, a Raspberry Pi 0W, Raspberry Pi 0W, and a Raspberry Pi 3A Plus. So if you can't get enough horsepower out of that for your school project, I don't know what to say. But yeah, it's really straightforward. I'm not going to go through, the whole build. I'll put a link to this part down in the description for today. This is widely available on Amazon. At last look, they had a couple hundred in stock, I think it was. But anyway, it's really straightforward with your standoffs. The only thing I will tell you to keep an eye on is the USB port on the 3A Plus had a really long ear sticking out. And I just used a set of close cut cutters, like those, and trimmed the ear, but leaving it in the bed of solder. That's right down in there. I can't find my pointer. There it is. Right down in there is that ear. And it came uncomfortably close to the micro USB on the 0W for me, because if there's any force, it was, a fraction of a millimeter clearance. So I just trimmed them both off. But again, leave it in the bed of solder, because you don't want to cut your connection off. All right, so that got him on his way. And hopefully he should have those parts today or tomorrow. Okay, back to work on our 0W SpyComms device. So what we're going to do today is I'm going to walk you through creating the micro SD. We'll get it into the 0W. We'll do the first boot on the 0W, make sure everything is working, and then we'll go ahead and mount it in a case and continue working from there. So let me switch over and I'll see you guys on the desktop. All right, folks, we're over on the desk now. So to burn this off to a micro SD, or yeah, you're going to have to do it to micro SD no matter what, but I'll let you figure out, again, the mechanical connection to your computer. We're going to use the light version. In other words, no GUI, no user interface. I'm going to go ahead and select my 32 gig. And we're going to start this flash. And you won't allow this app to make changes to your device. Yes, if that is enabled on your system. We should be starting off here in a minute. There we go. Okay, so now that that's completed, there was one thing I did overlook, and I want to show you this. At least for the purposes of our project, we want to make sure that you eject on success is disabled, because otherwise you're just going to have to pull the card back out and put it back into your computer. But real quick, let's run over there and let's go to there we go. Why did that not load? There we go. Always a little bit of problems when you try some do-it-yourself. Sorry. Damn it. recording in a narrow window so I don't have to completely empty my desktop. So now we've formatted now we've formatted it, we've burned the image on there. So this is our operating system on the Raspberry Pi card that we just made. So there's no particular order to this, but in the next steps, the first thing you need to do is create a file and just call it SSH for secure shell. You're going to get prompted that it doesn't have an extension. That's correct, because if you'll notice, I deleted. So here, let's make a new one. Just as an example, SSH 1. On boot, it will see this file if it was named. Well, actually, I can just leave it named SSH. But anyways, it's a 0-byte nothing file. So here, I'll delete it. And let's create a new one. Just so I don't go too quick, because this tends to get missed. SSH is our file name. You'll notice .txt is the extension. There's no need to keep that. In fact, we want to get rid of that. So just Shift N or select it with your mouse and delete it. You'll get a notification that there's no extension. That's okay. That's what we want to do. The next thing we need to do is in our command line text file. Now I'm using Notepad++. I would recommend that because Windows Notepad can do some really funky stuff if you're not paying attention. So what you saw there is I have a cheat sheet on headless RasPi because there's some goofy stuff that will catch you. All right, so in the command line.txt file, we're looking for this root wait command. And just past that, we want to put a dead space, paste in our command, and make sure that we have one dead space right here. There needs to be a dead space between each command. So that's one thing that will bite you in the butt. So just make sure that you have that dead space. So we're going to save that off. I'm going to move this over. And the next thing we're going to edit is this config.txt file, which is, whoops, that opened a notepad. So in our config.txt file, we're just going to scroll all the way to the bottom, do a hard carriage return, and we're going to add this dtoverlay. And we're going to save that. If we can get this off the screen. All right, and that's pretty much it. So we've edited our command line.txt file and added to load the OTG driver and the OTG or the USB Ethernet, I should say. And in config.txt, we've actually added our overlay for that. We've created our SSH file. All right, so now let's go ahead and eject this from our system. Whoops. Okay, we've now ejected. Let me grab my RasPi. Actually, I'll use this one. So now you can go ahead and insert the RasPi into your you can. Just to reiterate, your USB cable, micro USB cable, power only, power and OTG or on the go. So to connect to your PC, you need to be hooked up to this port, to the second port. For power only, you need to hook up to that port. Still on the computer, you're going to plug it into the second port, the second micro SD port. I will show you, or micro USB port. I will show you a picture of the right one. And we're going to boot up. It takes it a minute for the 0 to boot. This is the one part that gets a little tricky. Can be a little tricky. You have to wait till it boots here. There we go. So now it's there as a USB device. The first time you do that, it's going to try and install some components. Just let it go ahead and do it. It's a USB, I found it right here. USB Ethernet RNDIS gadget. Horrendous gadget. Okay, and now our device should be booted up, but let's give this a test real quick. And to find it on your network, it's ping Raspberry Pi. We want to do -4, which will give us back the IPv4 address. Now, there's a catch to this. You don't necessarily have to do this step. I like to know, did it assign it a static IP address, which is unlikely. But if you're using a micro SD that you used on another project, this can come back to bite you in the butt. That's why I show you this. So if you did not create a new micro SD, you just took one out and bunged it into your 0, you're going to run into that. So that's why I'm going to point that out to you and show it to you. So we want to, using PuTTY, which is our SSH client, we want to open up Raspberry Pi. And we should get a connection, and we did. I hate that it never pops up in the center. Default login is Pi. Default password is Raspberry. And we're in. Now that we're in, the first things we want to do is sudo RasPi config. The very first thing you do, no matter what, is change the password. I realize I might go a little fast through these, but you can always rewind. Okay, now we've changed our password. The next option we want to do is change our host name away from Raspberry Pi. The reason being, if you have multiples on the network, it's going to cause confusion. Each computer needs to have a distinct name and a distinct IP address. So just think about it. You're not going to have, you're in your neighbor's house called Therm, and they both have the same street address, 121 and 121. It's going to confuse the hell out of the mailman. It's going to confuse the hell out of anybody that needs to go to that address. So give it a distinct name and a distinct address. So, because we're playing around, I'm going to name this one Shiznits. No, let's name, yeah, Shiznits works. I don't know why I picked Shiznits. It's just something silly. Network settings, host name. Next thing you're going to need to do is enter your Wi-Fi, your wireless LAN. You can just multiple key through this. So we're going to set up our LAN country as the United States. SSID in this case is driftless. Oops, ext. Enter your Wi-Fi key. Let's see, network options. Now we need to come in. Oh, we changed our host name. We changed our Wi-Fi LAN. I'm not running off a sheet here. I'm doing this off the top of my head. There's really nothing else we need to change here. That can be handy. Oh, it's not going to run because I have to reboot after changing the name. Oh, it did run. Oh, that's all right. That's probably what slowed it down. So for my case, don't we have a, we should have a Chicago in here. There we go. You're getting these lag spikes as it, because it's trying to resolve the host name, which we just changed from Raspberry Pi to Shiznits, but I didn't reboot. So I got ahead of myself there. 1043 is correct. Okay, so real quick, let's go ahead and do our reboot, and then I'll be back with you. Okay, now going back to our previous trick, we're going to ping it by host name, which if you remember I did mine is Shiznits. -4 tells it to give me the IP version 4 address, and we did get assigned an address on the wireless LAN. So we know that that part of the config is good. So now let's get over there and let's go to Shiznits with our secure shell. Oops, did I spell it wrong? Yep, I spelled it wrong apparently. All right, so username again is Pi. Your password is whatever super secret password you set it to. Now, the next step we need to do, I'm just going to enlarge this a little bit so you can see what's going on. The overlay function of my screen recorder kind of screws up the way I can grab windows within the overlay. I don't know why, but all right, so the next thing we need to do is sudo apt update. And we're going to update this machine with all available security patches and any application updates. This will take a little while, so I'll let this run and I'll see you in a second. And I'm an idiot. I should have left it recording so you can actually see the progress, but that's okay. You'll see it in a minute. So right now it's downloaded available package lists and it's reading through them to see what's available for update and that all dependencies are resolved. So we've got 41 packages that can be upgraded. So the next thing we want to do is sudo apt full upgrade. You could also just do sudo apt upgrade, but because there is a new release of the full RasPi, I just want to make sure that we catch all updates that are available as part of that upgrade. It may or may not have anything available, but I want to just give that a shot and make sure we get everything. Okay, this is going to take a while. I will let this run and I'll see you guys momentarily. Okay, and that's our updates done. So that took, elapsed time was probably, in reality, about 8 minutes. It's one thing with the Raspberry Pi Zero, it's a little low power, but it's fine. Okay, so as I said, let's go ahead and do a reboot. And then I'll see you guys back here in a minute as the device shuts down and restarts. Okay, so now we've logged back in. We have changed the host name. We have changed our password. We have rebooted. We have completely updated. So now, depending on your intended purpose, the load of applications will change. But for the first one, we're going to install telnet. Telnet is a way to connect to other computers over the internet. It is not secure. It is not encrypted, but it's a good way. Whoops, sudo. Think about it. I'm thinking and typing instead of sudo apt install telnet. So yeah, I'm thinking about what I want to do and not thinking about commands. So again, telnet will allow us to connect to other computers. I'll show you at the end, we will connect to a bulletin board system just to test the connections and make sure everything works. Okay. The next one we're going to install is for email, text-based email, which is Alpine. These are the ones my daughter and I have chosen for this project. You can look around. There's a ton of different mail packages that you can use. Telnet, there is only one client, but there are quite a few command line email clients. I prefer Alpine because I used Pine for decades. So it's very quick and easy. It's simple. You know, KISS principle takes up a lot of benefit. You'll see in a lot of things I do, I try to keep them as simple as possible so that anybody can follow behind me and do it. The next one we're going to do is called neofetch. Neofetch is a handy little utility just to see, and again, I'll walk through and show you these real quick when we're done. Neofetch is a great utility just to see the status of your system, kernel updates, available memory, and etc. Especially if you're running multiples, you can open the SSH sessions side by side, run neofetch in each one and compare them. There's a lot of other ways to do that as well, but neofetch is kind of pretty, so I'll show you that at the end. Neofetch is installed. The next one is MC, or Midnight Commander. Those of you that have been around computers for a while might remember Norton Commander, which was a command line and GUI, command line way to give you a GUI to search around and edit files, delete files, rename files, and etc. There's some other reasons we're doing this, but my daughter and I still need to flesh out a couple ideas. She is adamant about having this be a tunes device as well, so something that carries music. So we would need, Midnight Commander would allow you to select the MP3 file or an M3U if you create a text file and save it as .m3u. That is your playlist. It's an old way to do it, and I was surprised she actually still remembered that. On that vein, we'll go ahead and install MPEG-123 right now. I'm still working on getting Bluetooth to work. It does not sync with my speaker. So I need to get the other Bluetooth speaker out of my van and see if that's the problem. It might not just like the device. Okay, that one error, well, it's not an error, it's a warning. It's actually kind of interesting. I need to go back and look and see exactly what they've changed. Okay, so we've installed our apps. Real quick, I'll show you telnet, which I showed you this last time, but we'll run through it one more time. We're going to go over to Vertrauen and just give it a visit. Just to make sure our connection is good, which we already know, but so we know our connection is working. We can now telnet out of the device and connect to another server on the internet. So we know we're good. As we update this, I'll come back and follow up with some other application changes we've made or things we want to do. No, because I'm going to download those later so we know we're in there. We're going to log off because we're going to log off. All right, the next one. So I showed you that one. We'll run Alpine, which is our text-based email. I showed you that one before as well. On the first run, you're going to get a lot of strange errors. The other thing I like with Pine is it scales very well to your screen size. So as you can see, I'm running 1280 by 1024 window, and it's scaled just fine. So we're going to quit that. Next one I'll show you is neofetch, which is what I was talking about. That's the system utility. So right off the bat, you can see which version of RasPi, right? The hardware we're on, the kernel version, the uptime, the number of packages, what shell we're running, what our terminal connection is, right? Our actual CPU and CPU speed, and the memory, how much we have available and how much is used. MPEG-123 is beyond the scope of this for right now. Midnight Commander, once again, gives you a way to navigate around your system, and you can edit files as needed. The menu is all down here at the bottom. These are function keys, so we can bring up an additional menu just to give you examples. And okay, and somehow I ran out of time on the recording. So yeah, we're going to issue the sudo halt, wait for the system to stop and completely power down, and that's it. I'll see you guys over on the bench as we mount this in a case. All right, we're over on the bench. We're going to go ahead and get out our case here. Make sure I got everything out of the box, and I did. That can go into recycling. The bottom to the case, top to the case, which would allow access to the pins if we actually had pins on this version. We don't. Here's our bag with our screws and our thermal transfer tape. We will get this built. I will plug it in here and boot it up. And then we'll go over to the desktop one more time and show you that it is connectable from here. I love these silicone mats. This is the third or fourth one I've had. I've had gouges and cuts and everything else in them. So once they're gone, I replace them. They're relatively inexpensive, and along with these other external cutting mats, they protect the surface of your desk very nicely. So by using the silicone one, you don't get melted points or anything else. Sorry, I cut my nails, and that pad is being a pain in the rump. Stay in there. There we go. Sticky, sticky, sticky. So again, we're in our case here. The 0W just sets down in the case. This is another advantage to Flirk, is they really think out. The other thing is you've got this little square here. You need to make sure, so if you remember that thermal tape is right here, make sure that you align that with that spot, because it provides the additional pressure to ensure a tight connection between our thermal tape on the processor and the raised platform in the case itself, so that we turn the case into a heat sink. Odds are the Zero would perform fine without it, but heat is one of your biggest enemies. Your two biggest enemies in computer are heat and power. So you need to make sure that you have as stable of an environment for both of those as possible. Do 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 do. You know what just dawned on me? I don't. Oh, I do have one. I had to make sure I had a USB power pack available. With that bit is just a hair too small. And there we go. So now we're up and running. I have a USB power pack. So you see that there's no magic. This one is power only. There's no data connection. So we're going to go ahead and plug that in. We're going to plug our Pi in. Again, this one for battery, this one for OTG or direct computer connection. I'm going to give this a couple minutes to boot, and then I'll see you guys back over on the desk. Right, we're over here on the desk now. I keep switching back and forth, and I hit the wrong button there. I'm just giving the 0W a chance to boot up. It's typically done in under a minute to a minute and a half. It will get longer if you start loading up additional services like Bluetooth. All that can add to the time, but let's go see if we are up. And we are. So let's go ahead and putty back into it. I saved my connection. Let's just keep this at a normal 80 by 24 window. Go ahead and log in. clear the screen and just show you there's no magic. There's our uptime, 1 minute. So yeah, we are now connected. Let's just do a ping first. Ping google.com. So you can see our connection is up. And it's definitely Wi-Fi. The connection is all over the place. Time-wise, you can see we're at 619, 25 milliseconds, 107, 85, 26. God, you gotta love Wi-Fi. It's all over the place. But it's convenient. So one more time, bert.synchro.net. And I will log in again. So there you go. There is our super sneaky spy communications device. Done and built. As soon as I get up to the main menu here, I will log off. Oh, I didn't want to do that. Okay, so we are on. Now we are offline. The one thing we're still debating on is the best way to shut this down. For right now, as you connect into it, you know, you've checked your mail, you've logged onto the bulletin board system or whatever. Sudo halt. In other words, that stops the system. Give it about 1.5 minutes to shut down completely, and you're done. One of the other options we're looking at is adding a power button through the case to detect a hold. So if the button gets bumped independently, nothing will happen. If it detects that the button is held for 2 or 3 or 4 seconds, whatever, the device will shut down. So I'll see you guys back over on the bench. All right, so we have now finished the initial stages of our project. I'm pulling out a scale here because that was one question from a viewer. This is a, I think, 5,000 milliamp hour battery. Yeah, 5,000 milliamp hour. I did test it on this one, on this battery. The Pi 0W, there's another one back here which is running, you can't quite see it with that camera angle, but trust me, there's 2 of them. That one running on the 5,000 milliamp hour ran almost 2 days of runtime. Sitting idle with maybe twice a day I logged into it to check the bulletin board and to play a game. So it's fairly substantial runtime on 5,000 milliamp hour. We are off. So there's a couple things I'm looking at. Number one is I will probably end up drilling a pinhole right around here somewhere. And that is to see my power light, my power LED. Or I may just come up and drill a hole. Actually, it would be back here, because if you think about the 0W, it's oriented in there this way. On this back side, I have pin access. If you remember, that cover can go on there this way to allow external access to the pins, but I don't want to do that. But it gives me headroom. The space is somewhere, actually we can probably, if I'm careful, pry that up. Sorry. We'll do it when I go to build that part of it. We'll actually do another video. But the idea is I may put an LED over here running off of GPIO. Have an LED here and a small micro switch of some type here. So if you hold down the switch, you know, if you bump the switch, nothing happens. If you hold down the switch for 3 seconds, we'll say, it institutes that shutdown command. The device shuts down properly. LED will turn off, and you know you're safe. So that's the end of part 1 of our discrete communications device. Yes, you need to carry a battery. but batteries come in all different sizes for these things. You could even, using an A+, 3A+, which is this one, you could conceivably build a larger unit with video output if you had the chance, better USB support, and on and on and on, and powered off of a LiPo battery. They even make 0W cases that support a small, thin LiPo battery. Beyond what we're looking to do, this is just a fun little project, but there will be add-ons, there will be applications that are installed for other purposes. Several other ones we came up with were something to do a live chat. So now that could be IRC, Internet Relay Chat. It could be, there is a command line client to, well, Telegram. There's a command line client to, I forgot the other one. I can see the icon. All my friends use it. My daughter uses it in Germany. I use it to talk to her sometimes. But anyway, there are command line versions of all of these packages, and those will be things that we add to it as we go. And again, I said she wants Bluetooth audio capability, which is may add a few more touch buttons to this, or do it all via command line. Not sure yet. We'll have to see where it goes. Anyway, that's it for today, guys. Be good, be well. Wear a mask, stay smart, be strong, stay mighty. That's the end of our Raspberry Pi 0W project. Have a great one, guys. I'll see you on Thursday.